on or off the vehicle. To test the switch on the vehicle, you will need a hand vacuum pump and a vacuum gauge. With the engine cold, remove the vacuum supply line from the switch, plug it, and in its place, connect the hose from the hand vacuum pump. Remove one of the other vacuum lines on the switch, and in its place, connect a vacuum gauge. Apply 20 inches of vacuum. If the switch is normally closed when it is cold, start the engine. As the engine warms up, the switch should purge vacuum from the hand vacuum pump and transfer it to the vacuum gauge. If the switch doesn't originally hold vacuum, it may be defective or it is normally open when it is cold. If it's normally open cold, then it should not allow the passage of vacuum after the engine is fully warm. In either case, you should be able to notice a change in operation from when the switch is cold to when it is hot. If it never holds vacuum, doesn't transfer vacuum as the engine warms up, or both gauges remain at the same reading all the time, replace the switch. Testing it off from the vehicle can be performed in the same manner by using a cigarette lighter to warm the capsule on the sensor. Once again, the switch should either transfer or block the vacuum from the hand pump as the tip of the switch is heated up. Replacing a thermal vacuum switch only requires a few simple hand tools. They include the correct size wrench for removal of the old switch, a drain pan, some Teflon thread sealing tape, and the correct replacement switch for your vehicle. First, begin all repairs with a cool engine. Then place a pan under the radiator and drain a sufficient amount of coolant from the radiator to prevent spillage when removing the switch from the cooling system. Remove any brackets or fan shrouds as needed to access the switch. Then, disconnect the vacuum hose connection or connections from the switch. You may wish to label the hose locations to be sure of correct positioning on the new switch. With the correct size wrench or socket, loosen and remove the switch. Excessive scale and corrosion buildup on the bottom of the sensor can act as an insulator, causing the switch to send a late or no signal. To help prevent scaling and deposits on sensors or switches, we suggest a complete flush and refill of the cooling system every 2 years. Compare the old and new switches to ensure proper replacement. Place a small dab of pipe sealant or Teflon thread sealing tape on the threads of the new switch. To prevent cross-threading, begin by installing the new switch by hand. Do not, however, apply pressure on the vacuum ports of the switch, as permanent damage may occur. Carefully tighten the new switch with the proper size wrench. Reconnect any vacuum hose connections. Reinstall any brackets or the fan shroud if removed. Refill the cooling system with the antifreeze removed earlier, and you're done.
Let's briefly recap the steps involved for testing and replacing a ported thermal vacuum switch. First, perform a visual inspection. Look for cracked or broken vacuum ports. To test the switch on the vehicle, connect a hand vacuum pump to the vacuum source port on the switch and connect a vacuum gauge to one of the other ports on the switch. Apply 20 inches of vacuum to the switch. Now start the engine. If it is a normally closed cold switch, the switch should transfer vacuum from the hand pump to the vacuum gauge when the engine warms up. If it is a normally open cold switch, it should stop the flow of vacuum once the engine is warm. In either case, there should be a change in the operation of the switch from when it is cold to when it is hot. If it never changes, replace the switch. Whenever working under the hood, always begin repairs with a cool engine. Drain the coolant from the radiator into a clean drain pan. Disconnect the vacuum hose connections from the switch. Label their locations to ensure proper reconnection. With the correct size wrench, remove the switch. Compare the new and old switches to be sure of proper replacement. Place a small dab of pipe sealant on the threads and reinsert the new switch by starting it in the threads by hand. Carefully tighten the new switch. Reconnect any vacuum hoses removed earlier. Lastly, refill the cooling system with the antifreeze earlier removed.
The exhaust gas recirculation, or EGR valve, is one of the engine's most important emission controls for reducing oxides of nitrogen or NOx emissions. The EGR system recirculates a portion of the exhaust gases into the intake manifold, reducing the combustion temperature and therefore decreases NOx emissions. Common engine drivability symptoms associated with a defective EGR valve include an engine that idles rough or stalls at stop signs, poor engine performance or surging at highway speeds, and uncontrollable pinging or detonation. An EGR valve should be inspected every 12 to 15,000 miles for proper operation. There are three basic types of EGR valves being used on today's vehicles: a ported vacuum type, positive back pressure, and negative back pressure. As a result, there are different testing procedures for each depending on the type. This video will demonstrate how to test the two most common, the ported and the negative back pressure types. To determine what type of EGR valve your vehicle is equipped with, refer to a Haynes manual. Let's look at how to test EGR valves on the vehicle. The tools you will need include a hand vacuum pump, an inspection mirror, and a service manual for your particular vehicle. Whenever working on a vehicle with the engine running, make sure you are working in a well-ventilated area. Place the vehicle in park or neutral and set the parking brake. First, inspect all vacuum hoses going to the EGR valve for cracks, kinks, broken sections, and proper connection. If damage is found, repair or replace the hose. First, we'll look at testing a ported EGR valve. Run the engine until it is at operating temperature and shut it off. Disconnect the vacuum hose from the valve. You may want to wear gloves to prevent burns. In its place, connect a hand vacuum pump. Apply 10 inches of vacuum to the valve. The diaphragm plate should move upward, opening the valve, and should remain open for at least 20 seconds. If the diaphragm plate cannot be easily observed, use an inspection mirror to ease viewing. If the vacuum reading drops within 20 seconds, or the diaphragm plate does not move up, there is a leak in the diaphragm. Replace the EGR valve if a leak is found. Release the vacuum from the pump. Start the engine, and again apply 10 inches of vacuum to the valve. As the valve opens, the engine RPM should drop, causing the engine to stumble or stall. This indicates the valve is operating properly. If no change is noticed, the valve is not working properly and must be replaced. Next, we'll demonstrate how to test a negative back pressure EGR valve. With the engine off, disconnect the EGR valve vacuum hose, and in its place, connect a hand vacuum pump. Apply 10 inches of vacuum to the valve. The diaphragm plate should move upwards, opening the valve, and should remain open for at least 20 seconds. If the diaphragm plate cannot easily be observed, an inspection mirror will ease viewing. If the vacuum reading drops within 20 seconds, or the diaphragm plate does not move, there is a leak in the diaphragm. Replace the valve if a leak is found. With the help of an assistant, again, apply 10 inches of vacuum to the valve, and immediately start the vehicle and observe the diaphragm plate. The plate should move downward, closing the valve during engine cranking and startup. If the diaphragm plate does not move downward, replace the valve. Many late model vehicles are now coming equipped with either an electronic or digital EGR valve. These types of EGR valves are controlled by the vehicle's onboard computer and therefore require different testing procedures. Refer to a service manual for specific testing procedures on these types of EGR valves. An EGR valve may also be tested off the vehicle using a NAMCCO EGR tester. Refer to the directions included with the EGR valve tester for detailed procedures. The directions cover the three common types of EGR valves and list the specific tools needed to bench test each of them. If you remove an EGR valve for testing and find out